Hello everyone, I'd like to welcome you back. In this lecture, what I'd like to do is introduce you to vectors and scalars. Okay, so you're going to hear these terms, you're going to see them used in the text, and I want to make sure that you understand what the terms mean. Now, they might sound like very complicated ideas, but hopefully by the end of this lecture you're going to see that they're very simple ideas. What I want to do to get started is just give you a working definition of both, and then I'll give you several examples, and so that you can see that they really are simple ideas, and hopefully the examples will really solidify that for you. Okay, so I'm going to have to ask for you to allow me some artistic license here. It's a little bit difficult to write on a computer-based whiteboard, so bear with me here. But let's start out talking about vectors. Okay, let's get a definition for a vector. Let me pick out a color that you'll be able to see here. Okay, so first we want to talk about vectors. And forgive my handwriting here. Okay, a vector is something that has a magnitude or you could refer to magnitude as a size, and this is really important, and it has direction. Okay, so a vector has a magnitude or size and a direction. Okay, now a scalar differs from a vector. Okay, scalar differs from a vector in that it only has a magnitude, or we could refer to the magnitude as a size. Alright, so just to repeat, a vector has a magnitude or size along with a direction, and a scalar has only a magnitude or size. And if that's not clear to you, hopefully it'll be clear in just a moment when I give you some examples of both. Okay, now I want you to keep those definitions in mind, and now I'm going to give you an example. Alright, so let me just bring up a blank slide here and change pen colors. Okay, remember that you've allowed me some artistic license here. Alright, so I'm going to draw the ground. We've got our green grass on the ground. And now, on the ground, we have a box. Alright, so we have this box. And I'm going to pick the box up and carry it from where it is and set it down at a new location. So from where it started to where it ended up, let's say that was approximately like 10 meters. Okay, so I carried the box 10 meters away. So now my question to you is, does the 10 meters, does that quantity, is that a scalar quantity or is it a vector quantity? Now think about the information that you've been given or provided. If I pretend for a moment that there is no picture here, no drawing, and I simply told you that I moved a box 10 meters, what information have I given you? I've really given you the magnitude, haven't I? So this 10 meters really represents the magnitude, right? Or the size of the movement. And remember, I said to pretend that you don't have the picture in front of you, okay? Because if I just told you I moved a box 10 meters, you would know if I moved it up or down or right or left or east or west, what have you. You would have no idea which direction that I moved the box. You would only be aware of the fact that I moved it 10 meters. So 10 meters then, seeing that we only have been given a magnitude or size of the movement, really is a scalar quantity, isn't it? So when we refer to a quantity like 10 meters, and we know that it's giving us the magnitude of a movement or the size of a movement, what are we really referring to then? Is we're referring to distance. All right, so this 10 meters is really distance. So we know then that if we were to make a table here of vector quantities and scalar quantities, distance would fall under scalar quantities. All right? But now, what if instead of just telling you that I moved the box 10 meters, what if I said I moved the box 10 meters to, let me just change colors here. What if instead I said that I moved the box 10 meters to the right? Okay, now we have not only a magnitude or size, but we've also been given a direction. So now you know that I moved the box, how much I moved the box, and in which direction. So because you've been provided with the direction along with the magnitude, then we know that we're dealing with a vector quantity here. All right, and so when we talk about the vector quantity for movement, we're no longer just talking about distance. Instead, we're talking about displacement. Okay, so again, this was a vector quantity because we were given the direction and the magnitude. All right, so then I didn't really allow myself enough room to write it, but displacement, I'll put DISP so you can remember the displacement is the vector quantity for movement. Okay, so again, displacement provides us with magnitude or size along with direction, whereas distance only provides the magnitude or size of the movement. So we could either say that the object or the box was displaced 10 meters to the right, or we could say it moved a distance of 10 meters. Okay? All right. Okay, so now let's take another example. Alright, let's put our grass back up there. And this time, instead of a box, let's have a car. Alright? Let's have a little sporty yellow car. And for simplicity's sake, the car is going to move, or travel rather, the same distance that our box did. Alright, so let's just say that it moved a distance of 10 meters. So just to review, when we say 10 meters, we're talking only about distance because we've only been given a magnitude. Alright, distance is a scalar quantity for movement. Displacement is a vector quantity. So remember, displacement will give us the direction and magnitude of the movement, whereas distance, being a scalar, will only provide the magnitude of the movement. Now, let's say we want to know about how fast our object moved, okay? So instead of the box, we want to know how fast the car moved or traveled the distance of 10 meters. Alright? So when we talk about how fast something went, so we need to bring a time into this, okay? Because when we talk about how fast something went, then we need to look at the change in time, okay? And I want to show you a little symbol for change in. There's a little triangle or delta, okay? And delta really means change in. So what we're looking for when we look for how fast something went, we're really looking for the change of movement over time, right? So we're looking for the change in distance and the change in time. So our car moved 10 meters. And let's just pretend it did that in 2 seconds. In 2 seconds, it moved a distance of 10 meters. Okay, so now we can divide 10 and 2 and determine that our car moved 5 meters per second. Okay, because if it moved 10 meters in 2 seconds, then it really moved half of that in 1. So that's 5 meters per second. Alright? So when we have a quantity like 5 meters per second, what have we been given? Are we being given a scalar or a vector quantity here? Well, I'm not seeing any direction attached to it, and again, we're going to pretend like there's not a little picture up here. If I just told you that the car that I have moved 5 meters per second, you wouldn't know if it moved right or left, into the driveway or out of the driveway, east, west, north, south, what have you. You've only been given a magnitude of the of how fast it moved, right? And so that's a scalar quantity. And so the scalar quantity for how fast something moves is really known as speed. But what if instead of just telling you that the car moved 5 meters per second, instead I told you that it moved 5 meters per second to that's terrible, to the right. Alright, now I've given you a magnitude of how quick it moved, or how fast it moved, along with the direction of that movement. And so when you've been given the direction and the magnitude, you're being given a vector quantity, and the vector quantity for how fast something moves is velocity. Okay? Alright, so now you've been given two examples of scalars and vector quantities, and hopefully now if you were given a quantity, you could easily determine whether or not it was a scalar or a vector.